Hello everybody and welcome to the first video of the Coding on VeChainThor series. My name is Michael, but most of you will know me by Mirai83 on various platforms. And in this video I'm going to show you the requirements for Node and how to install a VeChainThor node on Linux. So let's get started. The system requirements for VeChain node are pretty decent, but there is one thing that you need to consider. The storage has to be SSD storage or NVMe storage. It simply has to be flash storage because it's very I/O intensive, and without flash storage, meaning if you run it on an HDD, the system will be very slow and it will take days for the first synchronization. So it's very advisable not to use HDD storage. For example, if you have a Synology or a QNAP network attached storage, it will run on those systems, but you will not be happy with them. So please use SSD storage, and that's the most important part for the system storage. You have to have 100 gigabytes available if you want to run a VeChain node, because the 100 gigabytes will be completely consumed with blockchain data if your first synchronization is done. We now have about 8 million and something blocks on the chain, and these 8 million blocks require those 100 gigabytes. If you're planning on running productive node on a productive system, it's advisable that you have about 500 gigabytes in total. So the 100 gigabytes will be consumed on first synchronization, and the other 400 gigabytes will be there to run the node for the near future. Because if you have to upgrade your node every 20 gigabytes, then you have a lot of downtime. For the RAM, it's also pretty decent. You have to have at least 4 gigabytes on a system where you want to run the VeChain node. It will run, but it will not be impressive if you do a lot of backend queries. If you're planning on running a stable productive system, you should use at least 8 gigabytes of RAM. And if you're planning on running a highly active full node with all the states and everything, and you need to get data from everywhere and everything, you should have 16 gigabytes, because that's gonna be a lot of block queries that you're gonna do on it. CPU wise, you can basically run it on every decent modern system. I have a Lenovo X230, which is about 8 years old, and it still runs pretty smooth. You have to have 4 cores. You will run it on a dual core system. It will start, but you should have 4 cores, especially for the first synchronization. That's going to require a lot of CPU time. So if you put in more cores, the first synchronization will be faster, and maybe after this synchronization you can remove the nodes, the cores from the system again, because the overall CPU usage in a synchronized node is not that high, even if there are big blocks. But you only import 1 block every 10 seconds. It's not a big deal then. That's it for the basic system requirements. Of course, if you scale or you're wanting to run farms or anything, this may differ, but this is a basic information if you're planning on starting a VeChainThor node. Now that the theoretical part is done, we will switch into a live coding session. And in this one, I am going to install a VeChain node from scratch on a Debian 10.6 system. And we will start it, and I will show you every step until we have an automatic starting VeChain daemon. So let's get right to it. This is a simple virtual machine running on VMware Player. I can show you the settings of this VM. And it's basically just what I said earlier. We have 8 gigabytes of RAM, 4 CPU cores, 20 gigabyte system hard drive and an additional 100 gigabyte partition or hard drive where the blockchain data will be stored. And I'm also going to show you how to mount the system and how to redirect the blockchain data to the custom directory. So let's close this, and then we will get started. The additional 100 gigabytes partition is not yet included, so we're going to check if it's there. And in Debian, we should be able to see an STB partition, and there it is, with 100 gigabytes. This is our drive we want to mount. But first of all, we're going to make a file system on it. So we're going to make fs.ext4 with a default X4 system. That's okay. And we're going to, oh no, we're done. First steps first. We're going to fdisk the STB storage. First of all, we need to create a partition. If we print the partition on this hard drive, we're going to see that there is no partition. So we're going to create a new partition with as primary, as partition number 1. First sector is our first sector, and last sector is the last sector. And now we're going to write this partition. And we're already done. We can check again if we go into the fdisk and check print, and then we'll see we now have the partition STB1 with size 100 gigabytes and type Linux. That's great. And after that, we're going to now make a file system on as X4 on dev STB1. Great. Now we already have our file system. This file system will be mounted in /VeChain. It's like on a pretty rooty mount point. But to do this, we're going to do this inside the F step, so it's going to be mounting automatically when the system restarts. And for this, I'm going to make a folder named VeChain directly at root. And now we're going to mount the system to this point. For this, I'm going to need the bulk ID from the STB1, and we're going to just copy that. And from there, we're going to etc fstep and locating the root point. It should be this. Yeah, there's the root mount point. And just paste it in here, what we copied earlier. Remove this. As mount point, we're going to use VeChain. As type, we're going to use X4. And the mount points will be read-write as user exec and 0, 0. So now the file is saved, and now we should be able to do mount VeChain. Okay, let's run. VeChain, that's right, why not? Okay, that's doing great. Oh yeah, got it. There we go. Now, if we do an ls on /VeChain, there you can see we have a lost and found. It's like a trash bin, and it's owned by root. But since our VeChain node will not be started as the root user, but as a user named Thor node, we are going to create this user now and set the permissions that this user can access this directory. So we're going to user at /m -m-d home for node, and with a console named bin bash, and the username will be for node. Now that we have this user on our system, we're going to let this user own this, so we're doing change own with -R for recursive, but we don't have any subfolders, and there should be, doesn't matter, but habits. Node and for node on VeChain. And if we now do the same command as earlier, we can see that it's now owned by Thor node, which is great. So now we have our partition mounted to the system and our permissions set to the right user. And now we are going to install all the packages that are required to build the VeChain binaries. As I said, we are on a Debian 10.6 system as a net install. Net install means it's a basic small system. There are no desktop environments or anything installed. It's just a basic plain root console, so there are not a lot of packages installed. And for this node to be able to compile, we're going to get the packages required from the Debian repository and also the packages required from external repositories. So we're going to do an apt get install, and now I'm going to put all the packages we need in here, and done. We only need the git package from the repository. Okay, I installed it earlier already, and now we're going to install Go. Go is a programming language developed by Google, and the complete Thor node is written in Go. It's very close to the hardware and very efficient in running complex tasks. And we can check the software here. If you go to golang.org/dl, there you can see the most recent version is 1.15.7. We're not going to use this version because I haven't tested it fully. We're going to use 1.15.6. And we could simply click in here and download the file, but we're going to need to do it on our VeChain node. So we're going to do wget and then put the domain in here. The link is like there. 1.15.6 Linux.rd. And okay. MD. And sometimes it's fast, sometimes it's slow. You can see now I'm downloading with 27 gigabytes a second. That's pretty fine. But I also had like 1 megabyte or like 500 kilobytes. It depends, but it's been fast the last 3 times. And after downloading this, we're going to extract this directory, this file, into user local, and with the switches XZF, and take in the file we downloaded recently. After this, we have to make the binaries executable. So we're going to change mod at X and doing this for user local go bin go. Now we have the Go file ready to start, and we can remove the file we downloaded. Now also Go is done, and that's basically it for all the system packages required for our node. On a Debian 10.6, we only need those 2 packages, which is awesome. It's so easy to handle the VeChain node. It's really, really, really awesome. And now we have to set some permissions and some settings to efficiently run the VeChain node. As I said earlier, the Thor node will run as the user Thor -node. And for this user, we have to set the open file limit. We have to increase the open file limit. If we check it now on, if we check u limit /sn, we can see that it's set to 1024. It's for the huge user, but we can also do Thor node and do the same u limit vchain/sn, you can see it's 1024, and that's not enough for a high load VeChain node, because the block data will be separated in a lot of files, and the VeChain node has to keep all those files open to efficiently get the data from the different files. So if you only have 1024, you can run in limits at a pretty decent rate, at a pretty soon rate. So we're going to increase those limits, and for that we're going to echo Thor node for the user, soft limit and proc with 16,384, and we're going to write this into /etc security limits.conf, and we're also going to write the hard limit for nproc and this, and we're also going to write the soft limit for no file, and the hard limit for no file. Okay, now that it's done, we should be able to do cut etc security limits.conf, and we have those 4 files we just added to the file. That seems to be right. Okay, great. That's done also. Now we're going to get inside our Thor user. And there we are. And now we have to set the Go environment parameters. There's the for the Go specific parts of the VeChainThor node to find to have been set, and that the Thor node will run smooth. For that, I am going to echo export path equals $path user local go bin to the profile file, and I'm also going to echo export go path equals $home/go also to the same file. And if we cut this file now, there you can see the variables I imported earlier are now being expanded and added with an additional path where the profile checked for binaries, so it can find the Go binary. And also here the default Go path is set to Go, which is also default, but it's set there, so everything is definitely set and no failure can happen at this point. And now to reload these settings, we have 2 ways to do it. We can either do simply exit and reload. If you exit from the user and insert the user again, now the settings are loaded, but you can also do a source.profile, and then it's also set again. And now we're going to make a directory with $go path /source. Go path. Okay, now there should be a directory. We go and go, and there is source. Okay, everything's fine. And now we're going to actually install the VeChain software. For that, we're going to clone the Git repository. It's git clone, and then the github.com/vchain/thor.git, and we're going to clone it into $go path /source/vchain/thor. The Git repository is only about 10 megabytes. It's done in a few seconds, and we're already done. And now we're going to cd into that directory, go source VeChainThor. And you can see there is now the clone of the GitHub repository, and now we have to make the files and compile the files so we have a binary to work with. And all we need to do is just make an make all, and that's basically it. Now the process will compile all the files, get everything that's needed for it, and after a few seconds there will be our binaries that we can run. There will be a warning and an error later, but that's nothing to be worried about. And after this we have our binary that we can put different switches on. There's the warning, it's simply to be ignored. And we will go through all the switches that we can run the VeChainThor node on, and we're close to our own VeChain node. So there we go, building Disco, building Thor, and we're done. No errors, great. Now that we are in, now that our compilation is done, we can go into bin, and there should be two files. Yeah, there are. It's one is named Thor, the other is named Disco. Disco can be ignored by now. It's just for the backend node distribution stuff. We don't need this. And if we call Thor without any argument, there are different switches that we can use. I'm going to zoom out a little so we can see them better. And we're going through the most important parts. With the network switch, you can switch between, not switch, but you can define the node that you want to run, mainnet or testnet mode. So VeChain has two blockchains, one mainnet and one testnet, obviously, and there you can define which one to synchronize. The data dir is also important for us because we don't want our chain in home.thornode.org.vchain.thor. We want to run it in /vchain. And so we have to modify this one. The cache value is okay, but you have to increase it depending on your use case. If you want to do intensive data scraping, you have to increase this value, but for our purpose, it's fine. Beneficiary is not important. It's just for authority nodes to a variable to be set where your gas rewards are going to. Also is gas target. It's simply not important for us now. API address is important for us because the VeChain node on default will run only on localhost. This means you can't access it from outside, and we want to change this. And the default port for VeChain is 8669. So we're simply going to set it later. API cores, it's not important for you if you want to run your own node. It's just important if you want other parties to access your node via different domains. But we're going to ignore this also. API timeout also, it's already set to 10 seconds. So we have a request timeout of 10 seconds. That's plenty. Not going to change this. The same with call gas limit and backtrace limit. We can use the default settings here. It has to be very specific if you need these values. And if you have questions about this, you can always ask in the development Telegram channel that will be shown on the last page of this session. Also, the verbosity level is with tree is pretty okay. Then we are going to be notified with new blocks. Max Pierce defines the most connections a VeChain node can have. It's on default set to 25, but you're never going to reach it if you don't have a public node. You normally have about 5 to 8 or 5 to 10 connections to other nodes, which is okay. But if you want to increase it, you have the boot node option, which is here. So you can specify other nodes that you want to connect to, although you don't have to. And we're going to show you this node, this option later too. The peer-to-peer node is the port on which the blocks actually will be exchanged. So where the different nodes are communicating with each other. It's set to a high port on 11.235, which is okay. We can keep the default value also. Also, the NUT value can be set to any, so it pretty much will be auto find your settings. Skip locks and pproof is simply to save storage, but you have less options on your node. So I advise you not to use it unless you exactly know what you're doing. And the disable pruner switch, this is a pretty important switch because you have to decide right away what you want to do with it. On a normal VeChain node, you're only keeping the states of the last 65,000 blocks. This does not mean that you only have the last 65,000 blocks, but the states of the last 65,000 blocks. This means you cannot query a VeChain a VeChain amount of an address that lies behind this value. So it's on Ethereum, it's basically the difference between a full node and a light node, or a full archive node and a normal node. And if you want to disable the pruner, if you do disable the pruner, then no states will be deleted, but also your hardware requirements on RAM and on storage increase a lot because all the states will be kept, and so the blockchain will explode if you keep all the states. On a normal setup, if you want to install a normal node, you don't have to disable the pruner, but if you want to do deep data collecting and data information like VeChain stats does, you have to disable the pruner to get all the information you need. With help and version, it's pretty, help shows this help and version shows this version. If you do a version, it should be 1.4. Yeah, you can see version is 1.4. And with all the switches discussed, we can now start our actual VeChainThor node. So to do this, we're going to call Thor with the network on main and the API address on 0.0.0.0.669. This means it will run on all the available IP addresses set on your system. This system only has two IP addresses, the local host address and the IP address where we connect to, so it can run on all of the IP addresses. On your node, you eventually have to change this value to a specific IP address because you don't want it to be available on the other network card. And the next switch will be the data dir, and we're going to set this to VeChain as said earlier, but we're also going to set it to this part just to be consistent with our directories. So we're going to add .org.vchain.thor, and that's it for the VeChain Thor directory. And now we are able to start our node. Nothing else is needed on a very basic installation. And now there is the node, and I'm going to cancel it right now again, so we can discuss the settings we see here. As shown earlier, we are running VeChainThor node 1.4 with Go 1.15.6. That's obvious because we both installed this recently. The network chosen is mainnet, and this is the block ID of the Genesis block, means block 0, the first block. The best block of this node is the Genesis block because we didn't synchronize any block. It was forged on the 30th of June in 2018, and we have here see the hard forks the VeChainThor blockchain already did. There are 3 of them, each adding new features to the blockchain. The master of this blockchain is this address. It's a dynamic generated wallet if you want to, and it has no benefit on this node. But if you are a authority node, this is important for you, and this is also important for you because the beneficiary will be where your paid VeThor will be sent to. Our instance dir is set to VeChain as we /VeChain as we set and as we defined, and if we do an ls on this directory, there are files in it. This means the first start already created everything necessary, and we can run it later again. The API portal is set to any IP address on this specific port, and this one here is the VeChain node ID for this specific node. It will not change as long as you do not reinstall it. And this is also the quotation you have to put in if you want to use a boot node. The external IP is not set here because we can't determine it. And for boot node to add to here, we are going to use the boot node switch later. But we're going to start the VeChainThor node once again. And as you can see here, this is already the pruner. The pruner started, but since we do not have blocks, we have no blocks to prune. So this will just, the node will just find some blocks, some nodes, and now we're going to synchronize blocks. This value here means the amount of blocks imported. So you can see we are now importing 3,000 blocks, 2,000 blocks at once. The first 300,000 blocks on the VeChain mainnet are pretty much empty. So the first 300k blocks are pretty fast. But after that, the big blocks come in and this value will get significantly smaller. So on a normal basis, you take between 5 hours in the best case, and up to a day or up to 2 days even if you want to synchronize the blockchain for the first time. To speed this up further, we can use boot nodes. But as I said, you have to know what you put in your boot nodes. I provide boot nodes for the VeChain community. You can use them and see them if you go to nodes.vblocks.net. Then you will be redirected to GitHub. And on this page, you can see all the information necessary for the boot nodes to be used. There's a mainnet node, a testnet node, and also a solo node, but that's not important. It's just a sandbox. But this, for the mainnet node, we need this information, this whole string. And we're going to copy it. And now run our VeChain node with the boot node switch. And just paste it in here. And yeah, it starts. And if we wait a little and for the blocks to synchronize, we can see that, okay, they're not bigger now. It can take up to, now we're getting bigger. It can take a little, but with a fast node, you can speed up the synchronization a bit more. Okay, now if we let this window run for about a day or something, we have a fully synchronized VeChain node, but it's just run as user. If we close the session or if we reboot the system, there will not be a Thor node running in the background. And now we're going to take care of this. For this, I'm going to exit the Thor node user, and we're going to create our AutoStart manager as a service. I did it earlier with a self-coded script, and but since Debian has a very nice systemd, a system manager for services, we can now simply create our own service, and we're going to do that in etc system, and we're going to name our service VeChainThor mainnet.service. And I could simply input the values here, but I'm going to write them down so we can discuss them a little. The unit information about this service will be description is VeChainThor mainnet node, and it's going to be started after network.target. The service itself, service will be defined as type equals simple. The user it will be run in will be Thor node. The group it will be run as will also be Thor node. No. And the working directory directory will be home for node 2. Okay, and now a very important setting. It's if you start your VeChain as a service, your VeChain node as a service, you also have to set the no limit filter, the no limit setting, the no file limit setting, limit no file equals 16384, the same value we inserted earlier. And now to the part where we start the Thor node, exec start equals /home /Thor node /go /source /VeChain /Thor /bin /Thor. That's the binary we are calling. The network is main. The API address is 000 dot 8669, and let's see what else we need. The data dir is /vchain .org.vchain.thor, and we're going to set the verbosity level to 3, which is default, but we can switch it down later to show what the difference is. And now we're going to set the install part, wanted by multi-user.target. And that's basically it. Okay, let's check if everything's right. Yeah, fine. Yeah, should be fine. Okay, now we're going to save the file and make it executable. For this, we are going to change mod plus X, and now the file is executable. To be able to run this file, we have to reload our systemctl daemon. So we're going to systemctl daemon reload. And now we can start our VeChainThor mainnet service as with systemctl start VeChainThor mainnet. This should be good. And now we can check our node with status. Jesus. And we can see it's already running, and we can see we're now importing 5,000 blocks at once. And at this rate, we're getting to a synchronized state very fast. Okay, that's good at this. And now we can check if there is a Tor service, if there's a Tor process running. Yeah, okay, fine. And we can check if the Thor node is connected. And here we can see also, 1, 2, 3, 4, 5. Sessions connected. As I said, most of the time we have 5 nodes connected, and as you can see, there is not our mainnet, this IP. This is the IP of the public node. It's not connected, and so we're just going to get into this again, add the boot node feature, copy this one, and paste it there. Oh no, that's not right. We're going to delete everything this. Now, since we've changed the daemon, we have to reload the systemctl daemon reload again. And we have to restart our service. Should be this, restart. And we can check now again with the status. And we see, okay, it's running. Yay, we are importing blocks again. And we can now check the net grep store, and we can see we are now connected to the node. So, okay, great. Our VeChain node is running. We have it set as a service, but it's not yet in auto start mode. So we have to do systemctl enable VeChainThor mainnet. This simply enables the automatic start after a system reboot. And to test this, we're going to reboot. This will take a few seconds. And after this, we're going to access the node, but only to prove that it's running and able to be accessed. How you access the node and what you can do with the different types of access you can do will be another video. But for this one, okay, great, we're connected again. I'm going to be root. Just make this gone. And if we check for a process named Tor, there we see we have our Thor process with the boot node. And if we do a netstat on the same, we can see our boot node is already started, but we are not connected to this node. We will be later. Okay, just wait for it, but we are connected and we will be running. And now we're going to do a check of the function of this. For this, we're going to use curl because the VeChain API is running as a HTTP service. I think I don't have curl. Yeah. I'm going to install curl. And after this is done, we're going to do a curl on HTTP localhost.h9/blocks/best. And we can see there are some information. We already are synchronized about 450,000 blocks. And if we check again, we are now 455. And check again. And now we're 456 blocks. Okay, now the node is running. If we check an htop, we can see that the CPU is used pretty fast. The limitation of this node is now the CPU. As I said in the beginning, you can now add some cores to the VeChain node, and it will synchronize even faster. But after the synchronization is gone, four cores is okay. So we have a running VeChain node. Everything is set to auto start, and you can basically start from here. We are now done with our live coding session. After this, I am just going to thank you all for watching. If you want to get in contact with me, you can look me up on Twitter. There I'm at Mirai83 _ you can see all the information we saw on this video on my GitHub page, github.com/Mirai83. And if you have any questions about development on VeChainThor, you can check the Telegram group VeChain Dev Community. All the awesome VeChainThor devs are in there. Not only if you want to use a blockchain, but also if you have questions about wallets or anything VeChain related, you can go in there and we will point you in the right direction. And yeah, we're done for the first video. I hope you enjoyed it, and I hope you come to watch the next video. Thanks all for watching, and goodbye.